All right, welcome. So today we're going to be looking at an introduction to rational functions. Um, Rational functions are basically equations where x is in the denominator of a fraction. Um, or you can think of it as something where we are dividing by x. So we're going to look at these in a similar way to how we were looking at polynomials and linear functions and everything that we've done up to this point. That is to say that we're going to look at how these functions graph um, and identify important parts of those graphs. So if we're looking at our notes, the first thing that it wants us to do is create a table of values and plot those points so that we can see kind of what the shape of this curve is going to look like. So what I've gone to is Desmos, put in a table, and I've went ahead and created that table. So if we look at the different values, right, we'll notice that the whole numbers are giving us decimals, right, because we're taking, say, 1 divided by 4, and it would give us 0.25. We notice that when we take the decimals, right, dividing by a decimal is going to give us a whole number. And then the most important thing is that when we're dividing by 0, it gives us an undefined value, which is another way of saying that there is no solution, right? Because we cannot divide by 0, right? Another way to think of it is that we can't take something and divide it into nothing. So if we plot all of those points, we notice that the points form a couple of little curves, right? We'll also notice that where it says undefined, right, there is no point, right? So if I'm reading the x-axis, or the parts where x equals 0, I don't see any points there. And if I want to see what that looks like when I sort of connect all of those points, we get two little curves with our undefined value right in the middle. So that undefined value, that line that our curves do not cross, is called an asymptote. And we'll see how that's spelled in a little bit. So when we're looking at our graphs, the most important thing is to be able to identify where the asymptotes are, and then that will tell us how the graph is going to look. So if I look at my second example, right, if I wanted to see what happens when I change it from 1 over x to 1 over x plus 2, I'm going to make another table. So let's turn this off. So as you can see, I've already made this table as well. So notice we get a very, very similar looking set of points. But what's different now is that the undefined value is at -2 instead of at 0, right? Because again, we can't divide by 0. So whatever I see in the denominator, whatever brings that to 0 is my undefined point. So if I see an x plus 2, I know that -2 or -2 is my asymptote. So when we graph it, we get the same shape, only it's been shifted to the left 2 spaces. So for our final little table, right, we're going to see what happens when we add our plus 2 after the fraction instead of including it with the x. So we look at our table, plot the points. So notice now we have the same shape, right? Our undefined point is still at 0, but notice where it flattens out, right? This plus 2 on the end has increased the height of all of our points by 2 spaces. So instead of flattening out at the x-axis, now it's going to flatten out at y equals 2. So the point where it flattens out on the sides, right, that's our horizontal asymptote. The line that our curves don't touch in the middle is our vertical asymptote. So when we look at the examples that they're going to want us to work, the first thing that we need to be able to do is figure out the equation of the asymptotes based on the graph. So I'm going to look at this first one right here. So like I said, I'm going to want to look at the line that they don't cross in the middle. So that would be like right about here. And then I want to look at the sides of my graph and see where it flattens out over there. So if I look at it, my vertical asymptote lines up with x equals 3. And my horizontal asymptote lines up with y equals 4. So when I fill in my equation, we said that the vertical asymptote makes a 0 in the denominator of the fraction. So since I said that one lines up with x equals 3, I need an x minus 3 in the denominator of my fraction. Since our y-axis has been shifted up 4 spaces, we're just going to put a plus 4 after the fraction. So for number 2, just to get another one, we're going to see the same thing. So my vertical asymptote lines up with x equals 2. And my horizontal asymptote lines up with y equals negative 3. So in my equation, my y-axis was shifted down 3, and my x-axis lines up with positive 2. So I need to bring that to 0 with an x minus 2. So another thing that we'll need to be able to do is look at the equation and determine what the shifts are just based on those numbers. So if I see the denominator of the fraction has a plus 3, remember that our vertical asymptote is going to bring that to 0. So instead of going 3 to the right, to bring positive 3 back to 0, I'm going to need to go left 3 spaces. For my y-axis, everything does what it looks like it does. So if I see a minus 5 on the end, that means I have shifted down 5 spaces. Finally, I'm going to need to be able to identify the graph based on the equation. For these, it's going to be a matching, right? I've got a bunch of graphs on the side. So if I'm looking at the transformations that we just wrote down, to identify this graph, I need to find something that lines up with -3 on the x-axis and -5 on the y-axis. So if I look at it, right, here's my -3 on the x-axis. Here's my -5. So the graph that I want is f. And that's all there is for our introduction to rational functions. See you guys next time.